Hello Year 11. Today I have set you a worksheet on exam questions on similarity and length, area and volume. And I wanted to talk through a couple of questions from the sheet so that you knew what to do. So question number 1 is about changing metric units when it isn't just a metric unit conversion for length. So question 1 is write 37 centimetres cubed in millimetres cubed. So what I know is that for 1 centimetre I have 10 millimetres, and that means that the length scale factor or conversion is that I'm multiplying by 10. So if I have 1 centimetre squared, which is the unit for area, then I need to square the conversion there. So I'm multiplying by 10 squared. So there are 100 millimetres squared in 1 centimetre squared. For volume, I need to cube the scale factor. So I'm multiplying by 10 cubed, which is 1,000. And so in 1 centimetre cubed, there are 1,000 millimetres cubed. Now I can use that conversion for 37 centimetres cubed. I'm multiplying by 1,000. And that means that I have 37,000 millimetres cubed. So this LAV structure helps you to do all of these conversions. In the past, I'd been telling you to sketch out a cube like this, and you know that there are 10 millimetres on every dimension of a centimetre cubed. So you'd be doing 10 times 10 times 10, which gives you your conversion of 1,000. But this is quite nice because we can use it on more complicated questions as well, involving similarity. So this next question, question 7 on your worksheet, 3 solid shapes A, B and C are similar. The surface area of A is 4 centimetres squared and the surface area of B is 25 centimetres squared. So I can fill in, I've drawn my table down here for A, B and C, length, area, volume. So for area, I know that the ratio is 4 to 25. Doesn't matter that it's surface area, it's still a ratio for area. The ratio of volume of B to the volume of C is 27 to 64. So I can fill in that ratio for the volume for B to C. And I know that if I want the ratio for the length, I need to square root these two to give me 2 to 5. For this one, I know that if I want the area, or if I want the length rather, I'm going to need to cube root. So the cube root of 27 is 3, and the cube root of 64 is 4. And I've got to work out the ratio of the height of A to the height of C. And height is a length. So these are the ratios that I'm after, but I have got 2 ratios. One for A to B, which is 2 to 5, and one for B to C, which is 3 to 4. And I need to combine these two so that I can pick out the ratio for A to C. And the way to do that is to make these two the same. So I'm going to make those both 15 because that is the lowest common multiple of 5 and 3. I've multiplied this one by 3, so I'm going to do the same to there. I've multiplied this one by 5, so I'm going to do the same to this one. And now I know that A to B to C is 6 to 15 to 20. And so I can say that the ratio of A to C is 6 to 20, and I can simplify that and say that the ratio in its simplest terms is 3 to 10. So those are the questions on the sheet that involve length, area, volume, where you might find this sort of table useful. The thing you need to know is that the scale factor for the length, if you square it, that gives you the scale factor for the area. And if you cube it, that gives you the scale factor for the volume. And then to reverse that, if you've got the scale factor for the volume, you cube root it to get the length. And if you've got the scale factor for the area, you square root it to get the scale factor for the length. The other type of question is about finding missing lengths in shapes that are similar. So I'm now going to look at question 4 on your sheet, where I have got 2 triangles, something like this, A, B, C, D, E. I'm told those are parallel, and that allows me to say that they're similar triangles because these 2 angles are the same because of corresponding angles. These 2 angles are the same because of corresponding angles, and then they share this angle. So because all 3 angles are the same in the triangles, they must be similar. And I'm told that EC is length 8.1 centimetres. DC is 5.4 centimetres. DB is 2.6 centimetres, and I have got to work out the length of AE. So what I've got here is enough information from these 2 sides, because they're the corresponding sides, to work out the scale factor of enlargement. So the smaller triangle has a length of 5.1 for this side, and the bigger has a length of 8.1. Now, although these are decimals, you'll probably recognise these as being numbers which appear in the 9 times table, at least 54 and 81 does. So if I divide by 6 and multiply by 9, divide 5.4 by 6, that will give me 0.9, and then times by 9, that will give me 8.1. So this is the side in the smaller triangle, 2.6, and I've got to find the corresponding side in the bigger triangle. So I need to use that same multiplier, 2.6 multiplied by 9 over 6. You will hopefully recognise that 9 over 6 is the same as 3 over 2. So I need to divide by 2, 1.3, and then multiply by 3, which is 3.9 centimetres. So that tells me what this length right here is. Hopefully that's enough for you to be able to answer all the rest of the questions on the worksheet. I will, in my email, give you some references to Dr. Frost videos which might help as well.